spotted a large object about 10 light years away moving toward Earth.
Imagine an enigmatic object drifting far beyond the orbit of Neptune, completing a single journey around our Sun every 25,000 years. The last time it began this immense circuit, woolly mammoths still roamed the Earth. Now we are just discovering this secret member of our solar system. How did astronomers finally detect it? And why is its highly unusual orbit forcing Planet Nine theorists to reconsider their hypotheses? Let's investigate. The discovery of 2017 OF201 began not by pointing a new telescope at the sky, but by looking back through 7 years of archived nightly images from two powerful instruments, the Victor M. Blanco telescope in Chile and the Canada-France-Hawaii telescope. For years, much of this data remained archived until astrophysicist Sihao Cheng and his colleagues Jiaxuan Li and Eritas Yang decided to re-examine it. They developed a sophisticated algorithm designed to layer, shift, and subtract images, a process that allows for the detection of faint movement. This technique made the object's subtle motion visible against the static background of stars. Eventually, they identified a point of light at a faint magnitude, revealing the path of a massive unknown object from just 19 scattered detections. The name, 2017 OF201, tells you the earliest image was from 2017, demonstrating our ability to find things in data long after it was collected. Based on its brightness, astronomers estimate its diameter at approximately 700 kilometers or 435 miles. While it needs official confirmation, an object this large is significant. Its self-gravity is likely strong enough to pull it into a roughly spherical shape, a key criterion for classification as a dwarf planet. For comparison, Pluto's diameter is 2,377 kilometers. In context, 2017 OF201 is one of the largest objects known at such extreme distances. But as impressive as its size is, the real mystery is its journey. To visualize this orbit, imagine the solar system scaled to a football field. Earth is a grain of rice on the goal line, and Pluto is near the 30-yard line. At its closest point, 2017 OF201 begins its journey just beyond Pluto at about 45 astronomical units, or AU. But then, it travels to a staggering distance of over 1,600 AU. That's equivalent to going from the 30-yard line to a point more than 30 times farther away than Pluto ever gets. This 25,000-year lap is not only vast, but also has an extreme eccentricity, meaning its path is a highly elongated ellipse. Coincidentally, its last perihelion, or closest approach to the Sun, occurred around 1930, the same year Pluto's discovery was announced. The entire history of human civilization, from the first cities to the digital age, has existed within a single winter of this world's long, slow year. This raises a profound question. How did it get there? An orbit this stretched out doesn't just happen. Standard models of solar system formation produce relatively circular orbits. To get an orbit like this, something powerful must have sculpted its path. So what could have flung this massive object into such a distant exile? One of the leading theories points to the early, chaotic days of our solar system, when the giant planets were still migrating. The idea is that 2017 OF201 had a close encounter with a giant planet, most likely Neptune. This wasn't a collision, but a powerful gravitational flyby, where Neptune acted like a massive slingshot, flinging it from a stable path into the elongated orbit it travels today. This process is known as gravitational scattering. However, some of the researchers suggest its history might be even more complex. They propose a multi-stage process. In this scenario, the encounter with Neptune threw it even farther out into the inner Oort cloud, an immense theoretical shell of icy bodies surrounding our solar system. This is less like a single powerful launch and more like a cosmic pinball machine, where each gravitational encounter alters an object's path. After spending billions of years in this cosmic wilderness, a later gravitational nudge, perhaps from a passing star or galactic tides, spent its orbit just enough to send it falling back inwards, where we have now detected it. The discovery of one large object hiding in plain sight raises a staggering question: how many more are out there? 2017 OF201 spends over 99% of its 25,000-year journey so far from the Sun that it remains nearly undetectable. We happen to be living in the brief observational window where it's close enough for us to see. The statistical implication is that the outer solar system is far more populated than we currently observe. If we found one object of this size in the tiny window of time and space where it was visible, there must be many more out there. Researchers estimate there could be 100 or more large objects with similar orbits waiting to be found, currently moving through the darkness beyond our reach. Because they're so far from the Sun, these worlds are pristine time capsules made of the same primordial materials that formed our solar system 4.5 billion years ago, giving us a clear view of the building blocks of planets. This discovery also complicates one of the most exciting theories in modern astronomy, the Planet 9 hypothesis. This hypothesis is based on the observation that several extreme trans-Neptunian objects share a clustered alignment, as if they are being gravitationally shepherded by an unseen planet. However, 2017 OF201's orbit is anti-aligned, pointing in the opposite direction from the main cluster. While a single outlier does not disprove a theory, it complicates the narrative. The team ran simulations that showed if the proposed Planet 9 existed, its powerful gravity should either line this object up with the others, or, more likely, destabilized its orbit and ejected it from the solar system entirely. The existence of this one defiant object suggests that the clustering of other distant worlds might be a statistical fluke, or that the cause is something far more complex than a single hidden planet. We have been introduced to a new object in our solar system, a dark 700-kilometer world whose 25,000-year orbit began during the last ice age. Its discovery is a powerful reminder that our solar system's frontier extends far beyond Neptune, into a realm where the Sun is just another star. Each new discovery redraws our cosmic map and challenges our understanding of planetary formation. This raises a compelling question. How many more of these distant worlds are waiting in the shadows? And what secrets of the solar system's history do they hold? What do you think this discovery means for the search for Planet 9? Let us know your thoughts in the comments below. To continue exploring the frontiers of our solar system, subscribe for our next video, where we will look at how future missions like the Vera C. Rubin Observatory could unveil these remote worlds.